Hello students. Today we'll start with the master and slave D and T flip-flops. Okay, we'll see today D and T flip-flops. Okay, so see, a master slave D flip-flop, as you can see here, can be configured using a master slave SR flip-flop. Okay, so what we do, we take one input D which is directly given to S input of a SR flip-flop, and when I complement the D, right, I complement the D and give it to the R input of a SR flip-flop. Okay, so this is basically a SR flip-flop configured as a D flip-flop. Okay, see, it's simple, right? So the function table, you can see here, function table of a D flip-flop. Okay, a master slave D flip-flop. It means, see, first thing is we know that our flip-flop works only when your clock is high. If your clock is 0, whatever be the state of input, you will get the present output same as previous output. Present output retains its previous state. Okay, however, your output will be reflected when your clock signal is high. Okay, so you can see here I have taken clock as 1. Okay, so now see, since D flip-flop is similar to SR flip-flop, when clock is high, S is 0 means your Q plus is 0. So here also when D is 0, Q plus is 0, and when D is 1, Q plus is 1. Okay, so we know that D flip-flop we have done earlier also. Our output follows input in the D flip-flop. Okay, so this is how is the function table. Okay, see, try to recall, we have done the D flip-flop. This is a master slave D flip-flop which can be configured using a SR flip-flop. Okay, so once we see the function table, this is how the symbol of a master slave D flip-flop looks like, right? So we know now, right, D is the input, C is the clock, Q or Q bar are my outputs, right, output and its complement form, and this symbol represents that the master flip-flop transfers its state to a slave flip-flop, okay, during the falling edge of a clock, right? So you can see here, now the master registers D input during the period when the clock is high. Okay, and the master of the master state is transferred to the slave at the falling edge of the clock. Okay, so this same thing is denoted here by means of this symbol. Okay, in that case, if you see any flip-flop, right, we have to, whenever you see a master slave flip-flop, this is how you need to represent, and sorry, here also you need to represent. Okay, so this is a function table. This is how a function table, the symbol and a basic D flip-flop configured from SR flip-flop looks like. Okay, now next is the T flip-flop. Like D flip-flop, we can configure from the SR master slave flip-flop a T flip-flop. Okay, see, this is a T flip-flop. So here we can configure T flip-flop using our basic master slave JK flip-flop. Okay, we can use this basic master slave JK flip-flop. Okay, now see here, when your T is 0, T is 0 means what? J is equal to 0 and K is equal to 0. Okay, so when T is equal to 0, it means J is equal to 0, K is equal to 0. The next state of T flip-flop, okay, equals its present state. Okay, it equals its present state. right? So for this, what you have to do is you have to look back for a JK flip-flop. Okay, for the JK flip-flop, we had seen the function table. Just a minute, I'll take you through the function table of JK flip-flop. Okay, I'll write down here. So for a JK flip-flop, if this is the J, this is K. See, I'll explain only for the clock pulse being high. Okay, and Q plus and Q plus complement. So J and K 0 0, clock will be high. Sorry, J and K 0 0, when your clock is high, so your present outputs will be same as previous outputs. Okay, when your J is 0, K is 1, output is 0 1. For 1 0, output is 1 0. For 1 1, here it is Q bar, here it is Q. Okay, I'll take you to the function table, just a minute. Okay, see, this is what is the function table of a JK master slave JK flip-flop, right? First thing is flip-flops will be active when your clock pulse is high, right? For 0 0, our present output will be same as previous states. For 0 1, my output will be 0 1. For 1 0, it is 1 0. If your J and K are 1, my present output will be, Q will be complement of previous state and Q plus bar will be complement of that complement. Okay, however, if your clock is 0, whatever be the state of J and K, our present output will be same as the previous output. Okay, so keeping this as a base, now we'll try to give the input to T flip-flop. Okay, so once we have the truth table, now it would be easier for you to understand that if I set T is equal to 0, it means I say J is equal to 0, K is equal to 0. So when J is equal to 0, K is equal to 0, it means our T flip-flops output equals its present state. Okay, so Q plus this would be equal to Q plus bar. Okay, we know this. Okay, now however, if your T is 1, okay, if our T is 1, it means J is 1, K is 1. Okay, so when J is 1, K is 1, right, you please recall I told you that present state will be complement of the previous state. So this Q will be Q bar. Okay, Q plus will be Q bar and Q plus bar will be Q. Okay, so this is same as JK flip-flop, only that input I have shorted. Okay, so depending on that, this is a function table. See, if the first thing is the clock works, the flip-flop works only when your clock is 1. Okay, now when T is 0, your present output is same as previous output. When T is 1, our present output is complement of previous states, right? And if clock is 0, again similar to JK flip-flop, okay, when your clock is 0, here similar to JK flip-flop, my present output will be same as previous outputs, Q and Q bar. Okay, and this is how a symbol of a master slave T flip-flop is represented, where again this is a input T, C is a clock, Q and Q bar are my outputs, and master, see, this symbol indicates that the master transfers its state to the slave at the falling edge of a clock. Okay, so we need to remember up till here. Okay, right with this. Okay, so we'll go for one of the numerical. Okay, see here you are asked to draw the master and slave output waveforms for a SR flip-flop configured as a D flip-flop. Okay, so we are asked to ignore the propagation delays as and assume the output to be 0 initially. Okay, so for this, basic is we have to keep this function table in mind. Okay, so according to this function table, our output, present output will be same as previous output if your clock is low, and the flip-flop works when your clock is high. So we know for a D flip-flop, output follows the input. So if D is 0, Q plus is 0, D is 1, Q plus has to be 1. Okay, so for this problem, first thing is, see what I'll do, I'll draw the QM, master ka output I'll draw. Okay, I'll draw the master's output first. So, right, see, I'll draw up till here. See, first work is I'll draw a master's output. Okay, see, up till here I have to draw first. Okay, up till here I'll draw, not up till the clock. First up till here I'll draw. Okay, now see, here D is 0, C is 0. Okay, now it is said that you have to assume, in the question you have to assume that the output is initially 0. So QM and QS you keep initially 0. Okay, so up till this point, this is how I get the waveform. Okay, this is how I get the waveform. Now I'll draw for QS also. Initially our output is 0. Okay, now I'll come to this point. I will come to this point, right? Now see, here okay, here see, D is 1. Okay, D is 1, but clock is 0, still 0. It means what? If clock is 0, we know that our output retains its previous state. Okay, so up till here my QM is, see, up till here my QM is still 0. Okay, now I'll go for QS. Again it retains its previous state, so here QS also is 0. Okay, not here. Okay, now I'll go to next state. Now up till here, see, when my clock is 1, clock has become 1, D has become 1. Okay, it means what? When clock is high, for a D flip flop, our output follows input. So our QM at this point goes high. Okay, it goes high. But see, here in this region, QM is high. Okay, since clock is high, but when I have to change the state of the slave, I have to wait. See, master has become 1. Okay, but we know that master transfers its state to the slave at the falling edge of a clock. Okay, so falling edge of a clock is which? This one. Just a minute. See, this is the falling edge of a clock. So up till here I'll continue. Slave, up till here I'll continue the state, and from here slave changes its state to 1. Up till where, that we'll see now. Okay, up till here it was understood, I hope so. Right? Now the next step, up till here I'll do. when D is high till here, right? Up till here I'll do. Okay, now see, up till here D is 1, clock has become 0. Okay, clock has become 0. It means what? If clock has become 0, my output will follow its previous state. Correct? So my QM is 1. Okay, and my slave's output is also 1. Right? Next. Next, sorry, I'll do up till here where my clock is still 0. Okay, when my clock is still 0. See, D is now 0, clock is 0. So, my QM retains its previous state and QS also retains its previous state. Okay. Now, at this point, see, at this point, clock is becoming 1. Okay, so now sorry, see here, when D is still 0, clock has become 1. D 0 and clock has become 1. It means what? Our QM follows input. Okay, output follows input. So my output QM goes to 0 here. Okay, it goes to 0 up till this point. Right? I hope you understood. Right? But see, what about the state of the slave? State of the slave will only change at see, this is the clock now. It will change only at this point. Okay, where my clock, at my clock's falling edge. Okay, so my slave's state continues. Sorry, state of the slave continues. Okay, up till here you can assume. Now, shh. Chalo. I hope up till here it was understood, right? So similarly, I have drawn here. See, you can see this. Okay, just now what I explained you, it is here. Okay, so you can just go through. I just showed you the steps up till here. Okay, further steps you can just go through. If any issues, we'll discuss it. Right? Thank you.